of Li square. So dimensional formula of inductance, energy ml square t power minus 2. Here current is a fundamental unity quantity, ampere power minus 2. Similarly, V is equal to IR. Here V is W by Q. So resistance is Q here is I T into I squared. So dimensional formula of resistance ml square t power minus 2. Here it is ml square a power minus 2. So dimensional formula of L by R ml square t power minus 2 by ml square t power minus 3 a power minus 2, which is time. In fact, no need to do this. It is a time constant in a large circuit. Directly you can write this. Here a man walking at the rate of 3 kilometers per hour. Rain appears to fall vertically. This is velocity of man. Velocity of rain with respect to man. So the true direction of rain. So here it is velocity of man plus velocity of rain with respect to man. Velocity of rain minus, we get true direction of the rain. So rain is falling in this direction. Once he increases to speed 6 kilometers per hour, it appears to meet him at an angle 45 degrees with the vertical. So it is 45. It is 45. It is 45. So this is, it appears to meet means this is velocity of rain with respect to man's new speed. So now velocity of rain, true velocity of the rain, tan 45 sin 45 degrees. If I take, so true rain velocity by man's velocity. Man velocity is 6. True velocity of rain is 6 into sin 45. 6 1 by root 2 3 root kilometer per. The body is projected from the earth at an angle with some initial velocity u square sin square theta by 2g. So this is h maximum. So that is u square sin square 30 projected at an angle with the horizontal. So u square by 4 into 2g. It's sorry, this maximum height here is given 5 by root 3. From this u square by g will be 8 into 5, 40 by root 3. So the range he is asking, range is u square sin 2 theta by g. U square by g will be U square by G is 40 by root 3. Sine 2 theta, 2 into 30, sine 60 root 3 by 2. That is 20 meters. A wind powered generator converts wind energy to electrical energy. Generator converts fraction of wind energy by the blades into electrical energy for a wind speed. So power output always calculated by using formula force into F dot V. So here I will write FV. Force here is rate of change of momentum m dv by dt plus v dm by dt. He fixed wind speed v, so then dv by dt is 0. F is equal to v dm by dt. So here amount of wind energy, that is density, is equal to mass per unit volume d by dt of density into volume. Density is fixed d by dt of area into length. So here it depends upon the length, area of cross section of the plate, that is fixed Vd into A dl by dt. So here we have a Vda into B. So V square dA. This is force. Power will be Fv, that is V cube dA is proportional to cube root. dV is relation between potential and electric field. Minus yi plus xj, r bar is xi plus yj, dr bar dxi plus dyj. So minus y dx plus x dy minus d of xy. So this is dv. V will be minus xy plus. So a man weighing 10 kg standing on the flat boat so that he is 5 meters from the shore. Shore is somewhere. Man is at 5 meter distance. So here system means man plus boat. So only boat center of mass means somewhere. Boat plus man center of mass will be somewhere there. Right. So this is the center of mass. Suppose man started moving in this direction. Man is a part of the system. That means there is no external force. Once there is no external force, no change in center of mass. So center of mass must be here. But in practical, man is moving towards right. So center of mass shift towards right. But since it should not happen, what both with to maintain center of mass here itself, both moves towards left by x meters. To maintain center of mass at the same position, both shift towards left by x meters. So that means now he walks 2 meters. So here both mass of the boat into it displaces by x meters from the center of mass. Here mass of the man, in fact he moves towards to right 2 meters, both moves towards x meters. Net distance moved by man is 2 minus x. So here it is mass of the boat is 20x. Mass of the man, so 2x equal to 2 minus x. 3x is 2x, here is 2/3. That means, so distance of the man from the shore, 5, actually initially towards right he is moving by 2 meters, but the boat shift by 2 by 3. So 3 plus 2 by 3 meters from the shore, that is 3.67 meters. Here, the next question. Racket works on the principle of conservation of momentum. How rocket moves upward, the hot gases acquire momentum in the backward direction mm, then racket acquires an equal amount of momentum in the forward direction. If plane is inclined at an angle theta with a horizontal body of mass m rests on it, coefficient of friction is mu. The minimum force has to be applied inclined plane to make the body to just move. In fact, this is weight. So this is mg cos theta, force component act downward direction. Once start moving, so the frictional force act in opposite direction, that is mu n, which is mu mg cos theta. So the net force acting downwards is mu mg cos theta plus mg sin. So that much force is applied to move the body upwards. A coin is placed on the gramophone record rotating at a speed of 45 revolutions per minute at some point. It flies away when rotational speed is 50 revolutions per minute. So, in fact, why it stays on the record, some centripetal force must be there. So, coin weight acts downward direction. So, normal reaction will be upward towards center. What is the force act? That is frictional force. Once it centripetal force dominates, then it flies away. So as long as frictional force is sufficient to balance centrifugal force, coin is on the graph record. If two such coins are placed, so here in fact r square omega square by r is less than mu. Omega square, omega is less than root mu. It to be, that coin to be on it. But here rotational speed does not depends upon, that is, if at all centripetal force dominates, so that all depends upon coefficient of friction g and distance, not by increasing the mass. Two such coins are placed, also it flies off with the same speed, 50 revolutions per minute. Once body is rolling on a horizontal road, then kinetic energy of a wheel will be kinetic energy due to translation plus kinetic energy due to, so it is half mv square plus half I omega square. Here half mass is 8, v here is r square omega square, I is moment of inertia 0.64, and omega is 15 radian, 15 square. So 4r square is, radius is 40 by 100, it is 2 by 5. R square is 4 by 5, omega square is 15, 0.32 into 15 square. So it is 16 into 45 plus 225 into 0.3. Here r square, it is I think 4 r is 2 by 5, 4 by 25, 1 more 5. So 144 plus 225 is 0.75, around 84. So it is 216 joules. A uniform chain of length 2 meters, L here is 2 meters. Let us say 2 meters weight is 4g. For 1 meter it is 2 kg. So here it is 60 centimeters, 60 by 100 into 2. And that is 12 by 10. So that is 1.2 kg. So 1.2 kg is hanging. To move this chain to top of the table, work done will be force into distance. Here F is 1.2 distance. So this total mass is not concentrated at one place. Here hanging part is 60 centimeter. So we'll take distance from center of mass, that is 30 centimeters. 30 by 100. We get 1.2 into this is 30 centimeter. 30 by 100.3 for 60 centimeters. For 2 meters it is 4 kg. Okay. Into 10, if mass into 10, totally 3.6 joules. Here free end of the spring is hanging to a rigid support. Because of weight, it's slowly allowed to come to equilibrium position by extending x, that is mg is kx. K here is mg by x. By stretching the spring by distance d is x, that is right. And the stretching in the spring is d. Okay. Stretching in the sense x is d. D will x is d means d here is mg by k. Suppose instead of allowing slowly to extend, just released all of a sudden. So the energy here associated is half kx square, which is nothing but totally elastic potential energy is converted to kinetic potential energy. So in this case, so that is 2D. At a pressure of 24 into 10 power 5 dyne centimeter square, 24 into 10 power 5, 1 dyne is 10 power minus 5, 1 centimeter is 1 by 100 square, 24 into 10 power 5, this is 10 square, 10 power 4 Newton per meter square. 1 liter occupies 1000 centimeter cube. So that is 1000 into 1 centimeter is 1 by 100, 10 power minus 3, 10 power minus 3 meter cube. So the RMS velocity will be VRMS root 3 PV by M. Root of 3, 24 into 10 power 4 into volume 10 power minus 3 by 20 grams, that is we convert into kgs. So you get here 72 by 236. 2 twice 36. So 10 cube 10 power minus 3. So you'll get here it is 10 power 4. 10 power minus 6, 10 power minus 3. So 10 power minus 1, right. So which is nothing but 600 meter per second. Here, Young's double slit experiment is made in a liquid. Nth bright fringe in liquid lies where sixth dark fringe in vacuum. So for a dark fringe, in vacuum is 2n minus 1 lambda d by d. He said sixth dark fringe in vacuum, that is 11 lambda d by d. 10th for bright fringe, yn is n lambda d by d. 10 lambda, but it is in liquid d by d. Lambda in medium is lambda by mu of that medium, but these two coincide. 2 plus 1 lambda by 2, right, is equal to 10 by d by d lambda by mu. Lambda get cancelled. 11 mu is equal to 10, 20. Mu here is 10th bright fringe 10 lambda by mu. Mu is equal to 20 by 11. Then circular ring, solid cylinder and solid sphere are rolling down from an identical inclined planes, and round-shaped body of mass m, it is at highest point, then potential energy is mgh. So when it reaches bottom, total energy it has is due to translation as well as due to rotation, which we used to write mv square into, here k is radius of gyration. For a circular ring, mr square is mk square. K square by r square is mu. For a solid cylinder, 2 by 5 mr square is mk square. So k square by r square is 2 by 5. For a solid sphere, it is solid cylinder, mr square by 2 is mk square. So k square by r square is half. So now a potential energy, that is V square, is 2gh by, which gains more velocity, means k square by r square is least. Here 0.4, here 0.5. So k square by r square is least for sphere. So sphere reaches bottom with more velocity. For two rods of different materials, identical cross-sectional areas, are joined face to face. Initially length of rods. If the temperature of the surroundings is it's rigid, right? So temperature is increased by surrounding temperature 30 degrees. First rod, some rod expands. Here this also, its expansion will be there. And because of uh, one exerted force on the other, so here it is there is a displacement x. So it has an original expansion L alpha delta t. It also has an expansion L alpha delta t. It may be alpha 1, it is alpha t. So here it is. Some temperature, the magnitude of the displacement, force exerted, Young's modulus is stress by strain. The stress on each will be Y delta L by L. So force will be Y, stress is force per unit area. Since they have both have same cross-sectional area, Y1 alpha 1, first one alpha 1, L1 alpha, L means here 1, alpha 1 delta t plus x. So second one, initial length will be same, y2 alpha 2, that delta, it is nothing but alpha 2 delta L is L2 alpha 2 delta t minus x by L. So he is asking the magnitude of the displacement x. So here it is y1 alpha 1 30 alpha 1 plus x, y2 y1 by y2 I write here, alpha 2 into L2 is 1, alpha 2 delta t 30 minus x. Y1 by y2 is 2, so we write here 2 alpha 1 30, here it is y into L only, this is not right, y into L. So here it is 2 times 30 plus 30 alpha 1 plus x equal to alpha 2 into 30 minus x. So from this we can calculate x value 2x, it is 2x plus x, 3x is 30 alpha 2 minus 30 alpha 1. X is 10 times alpha 2 minus alpha 1. We don't know which expansion is more that. Here he should rectangular back percentage increase in the length means in fact he must give it's a square block. Otherwise lengths are different. It's difficult to calculate percentage increase in the volume. Volume of a square block delta V by V is 3 delta 3L square by L cube delta L. So increase in percentage increase in volume is 3 times percentage increase in length, which is 3 times 0.2, which is 0.6. A given system undergoes a change in which work done by a system equals to decrease in internal energy. That is delta U plus delta W is 0. This is possible. That means it is an adiabatic change. Here 1 mole of an ideal gas cyclic process AB is isothermal process. Isothermal temperature is constant. See in the diagram in A dash to B dash, temperature is constant here only. Here the temperature constant is there, but it is not in other process. Here temperature change. So obviously this is the answer. But for other process also let us check BC how it changes. For BC, pressure constant. For B2C, pressure constant means here also pressure is obviously constant. For C to A, your volume constant, how pressure changes. PV here is NRT as volume constant. P is NR by V of T, P proportional to T. That means it's a Y is proportional to Y is Kx means it's a straight line passing through this. A coin is placed on a rotating turntable, just slips off if it is placed at a distance of 20 centimeters. If the angular velocity of the turntable is doubled, so omega is doubled, the coin will just slips off at a distance. So here I omega is constant, m r square omega 1 m r2 square omega 2. Here m is mass of the coin. Initially omega, now r square doubled to omega. So here r2 square omega get cancelled out. Then you have r2 square is r square by 200 by if angular velocity is doubled, so this is mr omega square. So R1 omega 1 square by omega 2 square is R2. So it is nothing but R2 is R by 4 because omega 2 is 2 omega 1. 20 by 4 that is 5 centimeter. Velocity of sound at the same temperature uh, of gas densities in terms of density 3p by m, so or 3p by mass by volume is density. So it's in fact gamma p. Let us take. Both are monoatomic. There is no role for gamma also. It is proportional to only 1 by density. So V1 by V2 is 1 by root rho 1 by, so which is root of rho 2 by rho 1. So which is 1 by 4, 1 by 2. An observer moves towards the stationary source, this source which is stationary. Observer is here moving towards the source. So from source he can listen sound. That means so source is traveling in this direction. Apparent frequency n dash equal to n into v bar minus v naught bar by v minus vs. Always source velocity you take positively. This has positive direction. Observer velocity is v by 5 opposite direction. Source is at rest. That is n into 6 by 5. That means 1.2 n. There is no change in wavelength when source approaches observer or observer approaches source. Two identical glass equiconvex lenses kept in contact in between filled with water. So we have here totally three lenses. 1 by f is 1 by f1 plus 1 by f2 plus 1 by f. So f1 and f3 are same because both are glass lenses. The new glass minus 1, 1 by r1 minus 1 by r2. R1 is this. R2 will be negative. Both radius are equiconvex. R1 and R2 are same. 3 by 2 minus 1. Here it is 1 by R plus 1 by R, 2 by R. So 1 by R. So regarding F2, 1 by mu liquid. Mu liquid here is 4 by 3 minus 1. First one is towards minus 1 by R towards right, which is 1 by 3 minus 2 by 3 R. The focal length will be 1 by r plus minus 2 by 3r plus 1 by r, 3 plus 3, 6 minus 2, 4 by 3r. So f will be 3r by 4. But here, from here, f and r are same, which is 3f by 4. Good question is potential energy of executing SHM. Actually, any particle which execute SHM in the mean position, its potential energy is 0. So kinetic energy will be half mv square. At the mean position, x is 0, kinetic energy is maximum, that is half k square. But he's given that already it has initially 15 joules of energy. Initially 15. So kinetic energy at mean position is so nothing is mentioned. We'll take as a reference 0. We already mentioned 15 joules is the kinetic energy. At the mean position, it has maximum kinetic energy. But the average kinetic energy is different from total kinetic energy. Total kinetic energy is 1 by 2 m omega square a square. Average is 1 by 4, half of it. So this he given it as 5. This becomes 10. So now total energy will be 24, 15 plus 10, which is 25 joules.